You are listening to The Vocal Technologist. Spoken tech for your ears.
Tools are getting better, output is getting worse. Both are true.
Yep.
And look, I reckon if you're keen to make sense of the tech world right now, Vocal Technologist is where we untangle the weird reality we're actually living in.
Right, because things are moving fast.
Exactly. We are taking a proper look at this massive pile of material that points to a very specific collision. We're watching the artificial intelligence software boom violently crash into the physical world and, honestly, into the limits of human endurance.
Yeah, and the narrative through line connecting all of this stuff is just a fundamental shift in how we work. Like, we are rapidly moving from a world where humans actually build the systems to a world where humans merely audit them.
Just checking the homework.
Pretty much. And by the end of this conversation, you're going to understand why human judgment is suddenly the absolute most valuable and, frankly, the most chaotic resource in tech right now.
Right. So let's start with how fast the baseline of capability is shifting, because this first example, it really sets the stakes. I was reading through the documentation on this JavaScript runtime called Bun.
Yeah, Bun.
It's a massive core piece of infrastructure for web developers, but it was just plagued by these incredibly complex memory bugs. We're talking about things called use after free or double free errors.
Right, so if you don't write systems-level code, memory management is basically hospitality.
Hospitality.
Yeah, like a program checks into a hotel room in your computer's RAM, it uses the space, and when it's done, it checks out, and then the room is free for the next program.
Makes sense.
A use after free bug is when the original program somehow keeps a copy of the key. Yeah. And it tries to just barge back into the room after a new program has already moved in and started unpacking.
Which obviously causes massive crashes, and it leaves these gaping security holes.
Oh, absolutely.
And fixing it is just brutal because the computer doesn't tell you who kept the spare key. You literally have to comb through millions of lines of code to find the exact moment the checkout process failed. Normally, untangling that takes a whole team of senior engineers a massive amount of time.
But the material we're looking at details this experimental AI agent, and it managed to rewrite the entire core of Bun in a completely different programming language.
Safe Rust, right.
Exactly, safe Rust, which physically prevents those memory errors from compiling. But the output wasn't just, working code. The agent actually produced a faster, smaller runtime that uses less memory overall.
Wait, I need to stop you there. I mean, if an AI can completely rewrite a core code base that cleanly and just solve complex memory bugs on its own, doesn't that mean human programmers are entirely cooked? Like,
Sure.
Are they having a lend? Because if the machine is building the house perfectly, what does the builder actually do to earn their paycheck?
It's so easy to look at that and panic, I get it. But the reality of the labor market is actually heaps more nuanced.
Okay.
Yes, AI is absolutely torching the market for junior programmers.
Yeah.
The jobs that are disappearing are the ones where the work product is simply code written to a very specific set of instructions.
Just translating blueprints?
Exactly. If your entire job is taking a blueprint and translating it into syntax, the AI does that faster
Yeah.
and cheaper. But paradoxically, this exact same technology is creating what the industry is calling the 100x agentic engineer.
The 100x engineer. I mean, that sounds like a Silicon Valley myth on steroids.
It does sound like hype.
How does an AI automating your job make you 100 times more valuable?
Because agentic coding doesn't normalize productivity. It doesn't just make everyone perfectly equal. It actually has an incredibly high ceiling, and that's based on tacit knowledge, experience, and architectural vision.
Right.
And that brings us to a crucial concept we really need to understand here, the outer loop.
Walk us through that. What is the outer loop?
Well, think of the inner loop as the actual typing of the code, the syntax.
Yeah.
The AI agents just dominate that now. But human engineers must own the outer loop.
Which means what exactly?
That means owning the constraints, the security sampling, the architecture, and the liability. Like, a human has to look at the AI's work and be able to explain exactly why it is safe to deploy to millions of users.
Because what if the AI hallucinated a vulnerability?
Exactly. Human judgment is the absolute bottleneck here. You need someone who can look at the whole system and say, yes, this solves the problem, it scales, and it doesn't break anything else.
So it's like hiring a fleet of wildly fast apprentice plumbers.
Mm-hmm.
They can lay 1,000 pipes in an hour, but you still need the master plumber to check the pressure, otherwise the whole house floods.
That is a great way to put it.
Yeah.
And if that house floods, you cannot sue the apprentice pipes. Liability falls entirely on the master plumber.
Right.
The economic value is no longer in laying the pipe, The value is in knowing where the pipe should go, and verifying it will hold up under immense pressure.
Which brings us to the part nobody is really talking about, how this shift is breaking the actual workforce and, honestly, the cities they live in.
Yeah, the human fallout.
If you are listening to this right now and feeling completely exhausted by the sheer volume of AI-generated emails or reports you have to review at work, this is exactly why. You are trapped in the outer loop.
Spot on.
And when the value of work shifts that drastically, the people doing the work get caught in the gears.
We're seeing a severe divide in the workforce because of this.
Oh.
Tech workers are basically splitting into two distinct camps, those who are amplified by AI and those who are entirely shaken by it.
Yeah, and the sentiment data is a bit ordinary. Burnout is surging across the board. Optimism is fading.
It's a weird dynamic.
It really is. Productivity metrics are technically up, but the quality of the output is highly questionable. People are generating more text, more code, more raw stuff than ever before in human history.
But the humans are the ones left cleaning up the mess.
Exactly. Fact-checking the hallucinations in that outer loop.
And notice how the messaging from the top is changing to reflect this burnout. The big tech CEOs have entirely flipped their script.
Oh, big time.
Not long ago, they were quietly warning of an AI jobs wipeout. The idea that AI would just replace everyone now. The narrative is that AI is simply a productivity boost that keeps people at the center of the process.
Is that a genuine realization, though, or are they just trying to stop enterprise customers from panicking and canceling their subscriptions?
Look, it's largely a realization that without human judgment in the loop, these massive systems become totally unmanageable. The models drift, the data degrades, and the output just becomes useless.
Right, the garbage in, garbage out problem.
Yeah, but they also desperately need to keep the public and regulators from completely rejecting the technology out of fear. So they rebrand it as a helpful assistant rather than a replacement.
But the economic chaos isn't just happening in Slack channels or PR statements. It's physically manifesting in the San Francisco housing market.
Oh, the housing stuff is wild.
The reports coming out of there outline absolute hysteria. We are seeing buyers successfully offering private shares of AI companies, specifically OpenAI and Anthropic, as payment for residential homes.
Which is an incredible physical symptom of an industry that is entirely disconnected from traditional economic gravity.
Wait, literal company stock being bartered for houses like some sort of high-tech feudal system? That is heaps dodgy.
It really is.
Instead of getting a standard mortgage, tech workers are transferring unvested or secondary market shares straight to the seller. Landlords are actively pushing out tenants just to sell into this hyped market. We're seeing properties going for $1 million over asking purely because the buyer threw in a block of private stock.
But you have to ask why a seller would ever accept that. Private stock is highly illiquid. You can't just sell it on a trading app to buy groceries or pay property taxes.
Exactly. It sounds like a massive financial bubble just waiting to pop. Why take the risk?
They're taking these deals because of pure concentrated FOMO, fear of missing out. The sellers are banking on the assumption that an illiquid share valued at $200 today will be worth $2,000 by the time the company eventually goes public.
So they're betting that whoever they overpay today will look cheap tomorrow.
Precisely. It's a localized economy running entirely on speculative future compute.
Actually, if you're finding this shift as wild as we are, maybe subscribe to the feed so you don't miss the next time we poke around this stuff.
Good call. Because if human judgment is the bottleneck burning everyone out in the outer loop, and it's distorting local economies, well, the only way these tech companies can continue to scale their valuations is by removing the human entirely.
Trying to escape the outer loop.
Right, that desperate need to escape the outer loop is what's driving the push for highly autonomous agents. I mean, what happens when AI agents start managing themselves?
That is the frontier. And the documents detail something called AI super forecasters.
Yeah, these are fascinating.
These are agents that are given a scaffold. Essentially, they're held by the hand through incredibly long multi-step research processes, and they are reportedly making crazy profits on prediction markets. They're comfortably beating human traders.
And a prediction market requires synthesizing massive amounts of disparate information, weighing geopolitical probabilities, checking historical precedents, and making a cold judgment call.
Stuff humans usually struggle with.
Exactly. This system forces the AI to break the question down. Maybe it writes a debate between two internal personas and then synthesizes a final probability. The fact that heavily scaffolded AI agents are beating human markets means the quality of their autonomous reasoning is crossing a very real threshold.
But doing that takes a massive amount of compute. Like if every prediction requires the AI to talk to itself and run internet searches for 3 hours, you'd go bankrupt paying the server costs.
Usually, yes.
Which is why the infrastructure side of this is the real story. Look at the voice and compute engines coming online right now. OpenAI's GPT-Live voice model can now hold a natural conversational flow for an entire hour.
And maintaining that flow is incredibly hard.
It is. But here's the kicker. While it is talking to you seamlessly, it's spinning off complex background tasks to larger, slower models like GPT 5.5.
So it's parallel processing disguised as a casual chat. The voice model handles the latency, keeping you engaged, while the heavy lifting happens in the background.
And meanwhile, SpaceX AI released Grok 4.5, which they're calling an Opus class model. They are pushing token efficiency to the absolute limit. It costs just a couple of bucks per million input tokens.
That's incredibly cheap.
To put that in perspective, 1,000,000 tokens is about 3,000 pages of text. You are essentially hiring a tireless researcher to read 3,000 pages for $2.
And when the compute gets that cheap, these massive, complex loops of agentic thought become financially viable. You can afford to let the AI think for a long time before it gives you an answer.
Which changes everything.
It does. And that ultra-cheap compute enables what the industry is calling agentic autonomy levels. This is how we categorize and manage risk as we remove the human from the loop.
How does that break down?
Well, low autonomy limits risk. It's highly reversible. If an agent writes a bad draft of an email or summarizes a meeting poorly, you just delete it. Minimal harm done.
But high autonomy is the edge of the frontier.
Right. High autonomy is where you have a manager agent that delegates tasks to hundreds or maybe thousands of helper agents.
Like a digital factory boss overseeing an assembly line of specialized bots.
Yeah. The manager agent continuously verifies the output of its fleet, cross-checks their work against the original goal, and only brings the absolute, final, critical decisions to the human user. It's designed to minimize the human bottleneck while attempting to maintain safety.
So, instead of me sitting at a desk searching a financial database, my AI assistant basically goes to the digital pub, talks to 3 other specialized AI assistants, researches the market, negotiates a stock trade, executes it, and just taps me on the shoulder when the money's sorted.
That is the ultimate goal of high-level agentic autonomy. You aren't doing the work. You're approving the final state of the work. You transition from being a creator to being the final constraint.
Right. So here is where the software dream violently crashes into physical reality.
The hardware wall.
Exactly. Because software can scale infinitely, and agents can talk to agents for fractions of a cent right up until they need a physical piece of silicon to run on.
You cannot AI your way out of a physical supply chain problem. No matter how smart the model is, it still requires atoms to function.
And we have this fascinating bottleneck happening with hardware right now. Nvidia has faced massive delays with its next-generation Kyber AI rack system.
And this system is an absolute monster.
It really is. It houses 144 Rubin Ultra chips designed to act together as one single giant computer.
The sheer computing density of that rack is staggering. The amount of processing power concentrated in that physical space is just unprecedented.
But to make 144 chips act as one brain, they have to communicate with zero latency, which means the physical wiring, like the microscopic traces of copper on the circuit boards, has to be manufactured to tolerances that basically defy physics.
And that's the friction point.
Yeah, that is exactly where the launch was heavily delayed. The manufacturing snags weren't in the software. They were on a single key circuit board. The most advanced artificial intelligence hardware on the planet was brought to its knees by the physical limitations of manufacturing fiberglass and etching copper.
It highlights a critical vulnerability in this entire boom. The software is evolving at the speed of thought, but it remains tethered to the speed of global manufacturing, shipping lanes, and physical logistics.
But when the AI does eventually get its physical hardware, the stakes change completely, because it moves from making text predictions on a screen to moving tons of metal in the real world.
Like the cars.
Look at Tesla's Cybercab production units. They are using heavier hardware with massively increased onboard memory, specifically to run entirely autonomous Level 4 models.
And Level 4 autonomy is a massive legal and physical distinction. It means the vehicle is designed to operate entirely without human intervention within certain defined conditions or areas.
And they aren't just simulating this in a lab. They're testing cars on public roads with absolutely no steering wheels or pedals.
Wow.
The safety net of a human grabbing the wheel in an emergency is physically removed from the cabin.
And that transition from digital software to physical mass, extends directly to humanoid robots, too. The documentation points out that humanoid robots are effectively decoupling capital from human labor.
What does that actually mean in practice, though, decoupling capital from labor?
Historically, if you wanted to double your factory's physical output, you had to hire twice as many humans. Labor was a continuous, ongoing operational expense. You paid wages every week.
Sure.
With highly autonomous humanoid robots, physical labor becomes a capital expenditure. You buy the robot once, you maintain it, and it works continuously across multiple shifts. Production capacity is no longer tied to how many people you can hire and manage, but simply how many robots you can afford to build and power.
And these machines are getting heavier and more powerful, which has international standards organizations totally scrambling.
Trying to regulate it on the fly?
Yeah, the ISOs are trying to draft safety protocols just so these massive pieces of industrial metal don't accidentally crush the humans they're supposed to be assisting on the factory floor.
Because the software driving the robot might be brilliant at navigating space, but the physical mass and momentum of the robot is entirely unforgiving. A software bug in an email draft is an annoyance. A software bug in a 400-pound hydraulic arm is a casualty.
And if we want to talk about the absolute extreme edge of physical constraints, we have to look at space. City Labs and SpaceX launched a satellite called BOHR. It's the first commercial nuclear-powered satellite.
Which solves a massive physical problem for highly autonomous systems operating in space: energy density and the reliance on solar panels.
Right, because solar panels are fragile, they need direct line of sight to the sun, and they degrade over time. This satellite is running on a beta-voltaic micropower source.
So how does that work?
Basically, instead of capturing photons from the sun, it captures high-energy electrons emitted by the radioactive decay of a hydrogen isotope called tritium.
So it's essentially a nuclear battery that doesn't rely on generating heat. Traditional space reactors use heat to drive a turbine, which involves moving parts that can break in a vacuum. This system just quietly decays, spitting out a steady trickle of electrons for decades without any moving parts.
So it's basically a gigantic glow-in-the-dark watch battery powering a satellite in orbit, totally bypassing the need for the sun.
Exactly. It provides continuous power, completely unaffected by orbital shadows or distance from a star. If you're going to put highly autonomous AI systems into deep space or extreme environments, they cannot go to sleep when it gets dark. They need a power source that is as persistent as the software itself.
It's just wild to think about.
It is, and honestly, this brings our entire discussion full circle. We started out talking about AI agents rewriting complex memory bugs in software code, which is a purely digital exercise. And we've ended up with autonomous cabs missing steering wheels and nuclear-powered satellites silently decaying tritium in orbit. The unspelled implication here is impossible to ignore. The physical world, the copper circuit boards, the housing markets, the heavy metal of robotics, the physics of energy, that is the final ultimate bottleneck for artificial intelligence.
It really is.
And as we remove the steering wheels and deploy the robots, human judgment in that outer loop is the only thing keeping the entire system on the rails.
It really leaves you wondering if AI development is ultimately bottlenecked by the physical limits of copper, fiberglass, and tritium. Maybe the true rulers of the autonomous age won't be the software developers in Silicon Valley, but the mining companies digging up the dirt. And look, if you want to keep tracking this collision between code and reality with us, head over to vocaltechnologist.cu. That's .cyu, Vocal Technologists. See you soon.
Spoken Tech for your ears.